Last lesson, we introduced the complex number. We learned that a complex number is made of two parts, or two terms, the real part and the imaginary part. Up until now, we've worked with numbers that are members of different subsets, but can still have operations done on them. For example, we can add natural numbers to irrational numbers, such as pi plus 1, which equals 3.141 and so on, plus 1, which equals 4.141 and so on. However, not all subsets can be added together in the same sense that we're used to. We cannot add a real number with an imaginary number to get a single number. This is why the standard form or general form of a complex number is a plus bi. There are some advanced algebraic properties at work here. While we're very far from exploring these, it's a neat concept to think about. We can think of a complex number to be a sum of two different numbers from two different sets. Let's look at a simple graph. Notice here that in the left circle, we have real numbers. And in the right circle, we have imaginary numbers or imaginary units. Finally, both of these circles, which do not cross together in the middle, are encapsulated within the larger box, signifying that both sets are subsets of the set of complex numbers. To express why these two subsets of numbers cannot be summed easily, let's look at 1 plus I. If we express I as its square root, we would have 1 plus the square root of -1, which in reference to real numbers doesn't exist. Thus, we cannot add further, and this is considered simplified. In order for us to perform operations on these complex numbers, we have to work around the different sets of numbers and make sure not to add the wrong set together. Let's say we have two complex numbers, 3 plus 4i and 1 plus 7i. In order to perform the required operation, we have to add only the real numbers together and then add only the imaginary numbers together. Thus, 3 plus 4i plus 1 plus 7i equals 3 plus 1 plus 4i plus 7i, which simplifies as 4 plus 11i. Let's practice a couple more examples. Number 1, 3 plus 5i plus 10 plus the square root of -25. Notice that before we can begin adding, we have to deal with the negative square root. 3 plus 5i plus 10 plus 5i. Now we can begin to gather the appropriate terms together. 3 plus 10 plus 5i plus 5i. Now that everything is together, we can simplify. 13 plus 10i. Number 2, 6 plus 3i minus 7 plus 27i. This time around, all square roots are already dealt with. We can begin to combine our terms together. But beware, this time around, one of our complex numbers is being subtracted from the other. Make sure to distribute the -1 to both terms of the second complex number. 6 minus 7 plus 3i minus 27i. This equals -1 minus 24i. We can factor out the -1, leaving us with -1 times 1 plus 24i. As you can see, complex numbers shouldn't be feared. Unlike complex fractions, the word complex here doesn't signify difficulty. These numbers are complex because it is a sum of two numbers from two unsummable sets of numbers. In the next video, we are going to look at multiplication of complex numbers. See you then.